Hello everyone, today I'm really excited to show you how to model single portal frame in Autodesk Advanced Years 2025. Create the new project by selecting my SI unit template. Delete. Type UN to check the unit system to make sure the unit is in millimeter. OK, type OP option to check it again in user preferences millimeter, and type OS to check the snapping. We take object snap on S3 and check the style of snap snap. Take on the grid intersection. OK, now I create a new building grid. Shift middle mouse, hold shift middle mouse, type is 0, 0, and press SH. Type 2000, 20,000 millimeter, 30,000 millimeter. Enter. Double click on the grid to check and change it to the edging. Now I use this grid line label the capital letters, change it A, B, C, D, and group to check the distance from the grid line A to B is 10 meter. It's not correct. Now I type 6 and the distance is 6,000 millimeter is correct. Single axis, no. Again we do the same procedure to check on other grid, and I use the numbers start from 1, 2, 3, and 4, and you can change it. Now I can change you only 3. The distance is 10 meter from the grid line 1 to grid line 2, and from the grid line 2 to grid line 3. Click close. Open the structure, the default structure. Click. In default, we use a IPE beam, and now you can change to the reference profile. Now I want to change the level, keep it 1, we use only one level, and the number of row you can change it 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Now I change it to 6. Enter. And the spacing, we keep the spacing 6,000 millimeter. Enter. You can change it if you don't want to use the equal or the same spacing. It's import from the grid line 1 or span 1. You can change it 5,000 millimeter and take it and change the span 1 to 5,000 millimeter. Okay, you see here the span change 5,000, and from the span grid line B to C also change keep 6,000. Now I want to use the equal distance. It distance from the grid line A to B and B to C is the same, 6,000 millimeter. Okay. Portal frame. The portal width I change it to 20,000 millimeter. Now delete it. Portal height I keep at the middle. The portal height is 7,500 millimeter. And we use the rose type 2 beams, and distance to the apex we update it to 10,000 millimeter. 10,000. For the leg column we use 6,000 millimeter, the standard length of the beam and column. And for the right side we also do the same, is 6,000 millimeter. So the slope is 8.53 degree, we must use the slope greater than 5 or 6 degrees. Is okay right now. Now I change it to the left side, and you can change the orientation. No, I keep it. Zoom in to check. Yes, everything is okay now. For the frame, we use frame 1. Now we want to change it. You can use the IPE section. Okay, now I keep IPE section and change it to 450, and this one if you use the same 450. And copy it to all. From the right side, we use 450 IPE section and copy it to the all, the same. Click on the rows and check on the home. Now I want to turn off the layer of cladding. Turn it off. Double click on this box again and check the section of the raster is correct or not. Yes, it's correct right now. You can check it. You can change from the wireframe to conceptual. Yes, it was better. Double click on this blackboard again. Frame, we use IPE 450, IPE 450 for the raster, and for the column we use the same. And for the transversal beam, this one we use IPE 240. You can change the direction also. Now it's important I change it to 100 millimeter. You see here the section of the shot update. You can change it the left side or right side. Now I keep it minus 100 millimeter. Gable post for the urn frame. Now I want to use the urn frame portal frame 1 here. This is the portal frame 1. And center pole. No, with this board we use the total length. Now I enable the total length, the number of pole. I use 4. In the example we use 4. Yes, you see here 4. In the start stand and the end stand we keep it the same 4 meter. In the profile for the gable post we use IPE 240. Now I change it to IPE 360. Okay, it's correct right now. I copy it to the urn cable grid line S. Change it to the portal 6. And you copy from the portal 1. Okay. Now you see here the section and spacing is the same with the portal 1. Okay, this is the portal 1. This is the portal 6. We will change the expressing letter. Don't worry. In Purlin, you can check and optimize the Purlin spacing by using the number of Purlin or by using the distance. Now I change it to the distance. I want to use the intermediate distance 1200 millimeter, and from the start point here we use a distance 300, and from the end point here the last 2 yield we keep it 1000. Okay, now you can change the value. You can 1200 millimeter. You see here the last Purlin update, and we use the alignment outside top. You can change the vertical offset here. Now I check on this one, right side, we copy from the left side, correct, and come back to the left side. Click on the advanced to change the section or the section. You can use the or section. Now I update to 140 and the thickness is 2 millimeter. You can flip the profile here if you want to change the direction of the C. Now I take it, and you see here the profile flip. Now I keep it in the default, and Purlin we do not use this friend. You can change Purlin and create a new Purlin here. Now I do not create new Purlin. Side rear, come back, check on the side rear. This one is the side rear. At the top we call it the Purlin. It's the same function but it's different in the location. Now you can use the distance. I tie it 1200 millimeter, and the start distance here I use only 200 or 300 millimeter, and for the intermediate distance I keep it 1200 millimeter. Yes, it is same. Now check it. Okay, now we keep this one, and view is the same for other, so you have to copy it all. Okay, and for the right side you can change it to the right side. Copy from the left side. Check here. Yes, everything is working fine. Advanced, you can change for the section. Now I use the same section, 140 multiplied with 2 millimeter thickness, and you can change the orientation or invert section or flip the section. Side pressing, you can change the side pressing. Now I want to change at the gable frame A. You select on the front and side pressing. Yeah, that's correct. Front. Click on the last column, post 1. You can disable. Check here, disable, and click on the post right column here. Now I want to enable it for the right column. Okay, and for the left column, I also enable it. For the post 2 and 3, you disable it. Click on disable. Okay, now we you can change the section or the pressing. In the default, come back, front column, post 1. Now we use L100 multiplied with 75 millimeter multiplied with 10. Now I keep this section you can change it pressing to the diagonal pressing, V pressing, etc. And the geometry, you can change the geometry. Now I come to the left side here. You can change it for the left side. Okay, the left side, photo 1 2, I use any ball, use the same section, and you can check here, yes, the same section, and it pressing. You can copy it all. Okay, if you want to apply it all over your structure, but now I want to keep it for the cable frame 1 2 and 5 to 6. Okay, in the case you should disable or enable. Do not enable it all. Okay, disable here, enable left side, again left side, portal 1 2, disable, enable. So you have to delete it's from 2 to 3. Now I want to disable, and 3 to 4 disable, and 4 to 5 also disable. Okay, now we apply the concept to the right side here, but this side we has a window, so you can use it pressing. You can change the pressing. Okay, now I use the right side, and you can just copy from the left side. Okay, and the right side, click on the portal frame 1 2, click on the ball, and 1 2, disable it. Rope pressing, we use at the left side, portal frame 1 2, and you can change the geometry. Now I keep the section is the same. Number of field, you can try it 3 or 4. Now I try it 3. Okay, 1 2 3, or you can choose 4. And offset, you can change the offset. Now I apply it the same. Yes, for the right side, I copy it from the left side. Now for the cable frame 2 to 3, I want to delete it, so you can use the left side, and 2 to 3, disable. Okay, now I want to add other pressing here, so you can add this. So keep this row pressing. We will add the column pressing here, and add the portal 5 6. You click on enable. Okay, or copy it from the portal frame 1 2. Yes, it's the same. Now come back to the side pressing, and left side, click on the portal frame 3 to 4, and copy from the portal 1 2. Okay, we apply it the same for the right side, so you can change on the right side, and portal frame 3 to 4, click on copy from the portal frame or you enable. Okay, correct right now. You can turn off this layer. Now I come to the side rail and check at the front. You at the same concept here. You can change from the number to the distance. I want to keep it 1100. In the start I use only 200. Yes, it's correct right now. You see here 200. Okay, copy it to the back side. Click on the back and copy it from the front. Yes, everything is working fine. You can check the intersection and change it aligned with this column. I think this one is not okay when you use this column intersect with the gut, so you have to move the direction of the column. Now you see the pole at the gable frame 4. At the frame 4 you have to change it. Gable post 4. You disable here. Okay. Continue to the rope pressing platform. Okay, you can use a internal platform via location. You can do add. Now I want to add a ball. You can add outside of the building or inside of the building. You can change it in the back, left side, right side, or inside. Now I want to add it in the inside of the building, and the portal 1-2 or at the portal 5-6. Now I use the 5-6 and enable. Okay, you see here 5-6 enable. Portal height you can change here. The portal height I keep it 3000 millimeter. In the section you can change the section to IPE 400. You see here this section, or you can keep it 300. Right beam you can keep it the same, or you can use a 400 here. Yes, now I want to keep it the same 300. And the y-axis, this one is the y-axis. You can change the section. Now I want to keep it the same. Yeah, 300. Okay, and you can add the secondary beam. Now I use the secondary beam IPE 200 and we change it to the machine column. You can enable it. Along y-axis here, yeah, front in the location and at the location. So we use at the front. Okay, enable. Now you can add the number of column. Okay, number of column I add it 4. And you can change the start distance. Now I want to use start distance 300, 3000 and end distance 3000. Okay, you see here. And you can change the orientation of the column. Okay, now everything is working fine. Continue to the opening to check the opening. At the front you can now I come back and delete this one. Platform inside and front here we use this ball. Okay, and opening at the front, personal door, gate frame. You see here the gate frame. Now I want to delete a port here, so you click on this one center at the center of the portal frame, and the length we use 3. You can use it 4000. Now I type it 4000, and the height I keep it the same 4000, and the extend to the extend length here I choose 0 millimeter. Okay, 0. Profile, this one is the header and this one is the post. You can disable post. Okay, correct right now. In advance you can change the position of the gate frame. And now I check the right side here, front and the right side. You see here the portal frame 1, 2 and gate frame, window frame. You can change the position of the window and start here. We start from the 1000. You can start from the 2000. Okay, start at the Y and the Z axis. You can change it to 1500 1500 millimeter. Now I keep this value high 100 millimeter, and profile you can use the header enable IPE 200. Advanced you can change the position. Now I keep everything in the default, and the right side we change to the 2, 3, and the personal door frame now at the center here, and we use the continuous port. This continuous port you can change it. Now I untick it. Yes, you can tick it. Okay, profile you can change profile. I keep default profile. Intermediate beam you can add intermediate beam. Cladding, rows, you can turn off the rows layer here on the cladding. Now I click to close it, and cladding. Okay, click on the layer. Connector or you layer. Okay, check on the cladding, this one to turn on. Double click on the watch again. Opening. Cladding. Rows left side. This one. This is the row left side. And we use the steel thickness 0.9. You can change this distance to 0.7 or 0.5. Now I use 0.7. Side A. In vertical, offset from support. Now we extend in both directions 500, overhang 500. Okay, now you can check here from the axis 500 here. Okay, in both directions. Okay, you can see here when you extend 200. Now I extend it to 100 or 50. Okay, now I keep it 50, and at this side we extend 500. Okay, keep it. Advanced, you can change position and the number. Now I use 5. Okay, 1 2 3 4 5 6. And you can change the spacing, the opening length 700 multiply with the opening height 2 meter. Okay, start. Now you can change here. Number 5, you can change the number 5. And the start is 10. Now I use 500. No, I use 2000. Okay. This one I use 150. 1500 millimeter. Okay, now we keep it. Check on the front or on the left side. We enable it and change the section. We use this thickness 0.7 millimeter, and we extend it to the top. You see here, we want to extend to the top 300. Now you can check on the front view. Yes, it's okay. Now I extend it to 300. Double click on it again. Cladding. Yes, we extend left side. Okay, now we use the right side. Copy from the left side. Okay, check here. And the front and a ball. I change the thickness of the cladding to 0.7 and I extend it to the top 300 millimeter, the same. Okay, now you see here. And for the back, we copy it from the front. Okay, now we complete the modeling. We continue to the steel connection. Thank you for your watching. I hope you enjoyed the tutorial. We will continue to the connection part. Thank you.